Well, hello, my students. You get to hear my voice even though I'm not in the class with you. How exciting! So, we're going to be doing multiplying radicals. Ooh, sounds exciting. Sounds exciting. So, we should know how to do this by now. To simplify the square root or any root of a number, you break that number up into the index power. So 50, the index is 2, so I need a perfect square. Well, 50 would be 25 and 2. So that would be 5 square root of 2. If I have the square root of 200, that would be square root of 100, because 100 is a perfect square in 2. So that'd be 10 square root of 2. So we're using the product rule for radicals, which is if I have a product underneath the radical, I can break that up into the radical of each factor of the product. So it'd be A, the nth root of B. But the reverse is also true. If I have a product of radicals, same index, I can combine that to one radical of that index of the product. So if I have square root of 2 times square root of 6, I actually can combine that to the square root of 12. So 2 times 6 is 12, square root of. Then I would simplify it, 4 and 3. So square root of 4 is 2. So in the math world, this is considered more simplified than this. So if I had square root of 5 times the square root of 15, you would say, okay, that'd be the square root of 5 times 15. Last time I write this step down. So that's the square root of 75. Then 75 I can simplify to 25 and 3. So it'd be 5 square root of 3. So if I had cube root of 4 times the cube root of 4, I'd say, well, they're both cube roots, so I can multiply the bottom or the inside, the radicand, and write it as one radical, cube root. 4 times 4 is 16. Then I would say, well, what perfect cube goes into 16? And that would be 8, and the leftover part is 2. So it'd be 2 cube root of 2. So if I had 3 square root of 2 times 5 square root of 6. Now, this is not foiling because there's not pluses or minuses in between the terms. So you'd have 3 times 5 is 15 times 2 times 6 is 12. So it'd be 15 times square root of 4 times square root of 3. 15 times 2 is 30, square root of 3. So if I had 2 times the square root of 3 times 5 square root of 6, I would say, okay, 2 times 5 is 10. Square root of 3 times square root of 6 would be square root of 18. Then 18 is 9 and 2. Square root of 9 is 3. So it's 30 square root of 2. So see if you can figure this one out for me, please. 5 square root of 6 times 2 square root of 10. So we go 5 times 2. Did you do it? I hope you did. 5 times 2 is 10. 6 times 10 is 60. Then we'd say, what perfect square goes into 60? Now again, you could prime factor it. 60 is 3 and 20. 20 is 4 and 5. Oh, there's our perfect square. So we'd break it up 10, square root of 4, square root of 5. I think I messed up. This would be square root of 15. Sorry about that. I lost the 3. So square root of 4 is 2. So it would be 20 square root of 15. Now if I had 5 square root of 3 times 4 square root of 3, 5 times 4 is 20 square root of 9. 3 and 3 is 9. And the square root of 9 is 3. So notice whenever you have a square root of a number and times the square root of the same number, it's really just that number. Because remember, square root is saying we want 2 of the same thing. So if I had 2 square root of 5 squared, you could write it twice. That's fine. Or you could just square both terms. 2 squared is 4. Square root of 5 squared. Square and square root cancel each other out. So that would be 20. So this is the end of video 1. There will be a video 2, and there will be homework given at the end of video 2. Oh, how exciting. See ya.